most developers are using AI the wrong way. And not just a little bit wrong, not something that you can make better in half a minute, in 5 minutes, whatever. They are using it wrong in a way where they're getting only maybe 10% of what these tools can actually do for them. And then you see them walking away frustrated and they think that the technology is overhyped. But the funny thing is, the fix, it isn't even technical. You don't need to be using better models, you don't need to change tools, you don't need a more expensive subscription, you don't even need to switch from Copilot to Claude or from Claude to Codex or from Codex to something else. No, the fix is in how you think about the thing that you're talking to. And that's basically it. It's a simple mindset shift and it takes about 20 to 30 minutes to learn. And once you've got it, every pull request, every refactor, and every single conversation with AI gets a lot easier. So that's what today is about. 5 simple ideas. And by the end of it, you will know more about working with AI than 90% of the developers using it every single day. And if you're not a developer, if you're just, a PM, a founder, or anyone using AI to ship a product, or anyone just using it on a daily basis to automate something or to do something for yourselves, then you can also stick around. Because these examples are going to be code heavy, but every idea in this episode will work for you too. I will be pointing out examples for people that don't code as well. So without further ado, let's get into it. So welcome to the show. This is the first episode of many, hopefully, and let me give you a quick orientation on how we're going to structure it. Each episode, I am going to take a single thing about working with AI, and it can be about code, it can be about design choices, product decisions, tool usages, basically the whole workflow around all of it, and I will try to make it as useful as possible for you to use on a daily basis, or for you to steal ideas from. I'm not going to do such thing as here are 17 tools that you should be trying right now. This is why you should be using Claude instead of Codex. This is why you should be using Copilot instead of this and that. No, I'm not going to do any of that. There are different tools for different things, so that's not my point here. Today, we're going to talk about the foundations. And I'm bringing you 5 foundations. So if you ever only listen to one episode of this show, it should be this one, because everything else that I will talk about in the following episodes will build on top of this. So let's talk about the first idea. So the first idea, which is going to be the mental model. And what do I mean by this? So before we even type a single word into Copilot or Claude or whatever tool you're using, you need to have the right picture in your head of who is it that you're talking to, or what is it that you're talking to. So let me paint this picture for you. Let's assume that there's a frame in front of us. On the left side, you have the AI. And AI is going to be your intern. And then on the right side, there you are, the senior developer. So both of us matter in the frame. But let's unpack this into a better explanation. So on the left side, AI being the intern. He is very fast, like extremely fast, because things that would take you maybe 2 hours to do, he can do it for you in 15 seconds. It knows a lot, it has read a bunch of documentation, knows about every single post that exists on Stack Overflow, it has read more open source code than any person ever will. It is tireless, it has no ego, it doesn't take coffee breaks. You can ask it to redo a function over and over and over again, and it's not going to get annoyed. But, and this is the part where most developers end up skipping, it doesn't know anything about your code base. It doesn't know the decision that your team made 6 months ago. He has no idea why there's a module that you're not allowed to touch because the person who wrote it left and nobody really understands it anymore. So you have this rule in your company which you don't touch this module ever. But he doesn't know that. It doesn't know absolutely anything about the code base. There's zero context if you don't give it to him. So when you talk to it like an intern, you have to do 3 things. You brief them, then you let them do their work, and then you always review what comes back. You don't just let the intern arrive in your team, Give him a random ticket from your backlog and expect him to finish it from point A to point B and, just ship it that way. You don't. You always have to review it. So it's the same thing with AI. Once again, AI, smart intern, okay? Make the analogy. So here's the sentence that I want you to remember from this point on. The quality of the output equals the quality of your brief. Does it make sense? The quality of your AI's output, of your smart intern's output, equals to the quality of the brief that you give him. In our case, in AI terms, our prompt. So if we give the AI vague instructions, we're gonna get vague code every single time. And when developers usually get a bad result, they like to blame the tool. They say that AI is dumb, AI can't really write real code. And in a sense, it is not fully wrong to think about AI being dumb. AI is really dumb if we don't explain things correctly to it. So, no, it's really not the AI's fault, in a sense. It is on us for not briefing it correctly. So, think about this in a certain way. You are always the one in charge. The AI is just there to do the work. So keep that picture in your head, and everything else that we'll talk about in this episode will make sense. And I've been talking a lot about code, but here's a version of the same mistake that has nothing to do with code, okay? Let's assume something else completely different. Let's go with something really simple and that works for a life basis, okay? So someone just opens up the chat and asks their AI to plan a birthday dinner. That's simple, okay? And you get a perfectly reasonable list of restaurants, you get fancy places with good reviews, you get a lot of different things, a lot of different cuisines, and it looks great. But then when you look at it, you're gonna notice that every single output that he gave you is restaurants that are 45 minutes away, which, is insane. And why is this? It's because you didn't actually give it a good prompt. You did ask for restaurants for a birthday dinner, so you got restaurants. But for example, one of your guests is vegetarian. Maybe the birthday person hates to go to Italian restaurants. But the AI doesn't really guess this. So it's not that he failed by giving you a list, it just didn't know about these little quirks. It didn't know about these rules that you had because you didn't tell him. So it's the same rule. Once again, the quality of the output equals the quality of your brief. And how do we brief it correctly? That's when we get to idea 2, which is the brief itself, the prompt. So there are, in my opinion, a lot of ways to prompt. And there are a bunch of recipes, and there isn't really a science behind it. It is not 100% a correct way to do it like this. There is no wrong way to do it either. There is the way that works for you. But let's just start from zero. Let's pretend we don't know anything about prompting, because maybe some of you listeners don't. So let's talk about the way that I like doing it when I have no idea where to begin with. And in my honest opinion, there are 4 elements for a strong prompt. So you're going to think of it as a checklist. You don't always need to be using these 4 elements, but if you are prompting an AI and you're not getting the results that you want and it isn't working for you, it's almost always because one of these 4 elements is missing. So are you ready for this? Here's the 4 elements: role, goal, constraints, and context. Okay? Role, goal, constraints, context. 4 elements for a strong prompt. So let's walk through them one at a time. Role. Role is really simple. It is about who should the AI be. So give it a personality. And you have examples like act as a senior developer, or act as a security reviewer, or even act as a tech lead doing a code review. And this small sentence, because you just need one sentence to actually set the role. But this one sentence changes everything that will follow up. everything on the output will be different because it shows, it gives him something to think about, okay? It pays attention differently to certain things. It's going to use different words. It'll flag different stuff on his output. And basically, it's not magic. It's you framing the AI to be something, to be someone, to give it a personality. And it works. It works and it costs you nothing. And it's a simple sentence and a prompt. So let's move on to the second element, the goal. And the goal is usually what you want from your AI. And not just a simple sentence like fix this. No, we're thinking about something like, let me give you an example. This function should filter out duplicate entries, but it's letting some through. So find the bug and fix it without changing how the function is called. So it's a clear goal, okay? You would know if this goal is achieved because you would understand that the problem is fixed. So the goal is what you want to have fixed, is the problem that you have at hand that you want a solution for. And it's usually what people already excel at, but at the same time, the mistake that most developers make on the goal is being too short. So you think that you're saving time by typing less, by saying just fix me or fix this instead, but you're not really saving time because, yeah, sure, you're saving 5 seconds by not typing a little bit more, but then you're going to spend 10 minutes going in circles because the first output that you got completely missed the point. Or even worse, you end up getting a fix that actually compiles, but then at the end of the day, it didn't fix the bug that you had or it didn't find the solution that you needed. So we talked about role, we talked about goal. Let's go on to the third element. The third element of a good prompt is constraints. Constraints are like rules. So it is what should the AI avoid? How should he format things? Okay? So this is one of the most important things on a prompt. And usually people miss out on it. And it's really something that changes everything. And examples of rules can be something like, for example, don't add any new libraries, don't rewrite the whole thing, just patch it, or something like, don't change how this is called from the outside. Just these things are rules so that the AI, so that your smart intern doesn't actually do the changes that you wouldn't do yourself. So constraints are how you keep the intern from going off and rewriting half of your application if he needs to, because they think that it would look better or that it would be more efficient. So without these rules, AI really likes to expand, polish, or try to improve something that you didn't even ask for him to do it. So imagine that you did this prompt without rules. He's going to do a bunch of changes that maybe you didn't want. And that means more review time for you. It means maybe looking at a massive change that wasn't even needed. And this is why constraints are important in a prompt. And then last but not least, the last element, the fourth element, in no particular order, by the way, it is the context. So context, as the name indicates, it's simply background that the AI doesn't have. As in, once again, the intern just joined your project. He has no idea about certain stuff. For example, what language are you using in this project? What's around the code? What matters about this particular project? Are we building for Windows? Are we building for Linux? You know? And this is the kind of context that you should also feed to your AI so that it knows exactly what you're working on. And context can be a bunch of different things, so I will not give you a big example, but context can be something as simple as the API lives in this folder, the UI lives in this folder, this is a project that does this and that, it is for a client that works on, yada yada. This type of context may actually shape the way of the output. So we talked about role, goal, constraints, and context. It is 4 things that you should always memorize. You don't know where to start? Think about these 4 things. Think of them as questions. So what is the role? What is the goal? What are the rules/constraints? And give me some context, okay? Memorize these 4 things and you will be building better prompts. So let's try to give you a little bit of a feel for the difference. So I'm going to talk about two prompts for the same task, okay? So let's start with the bad version. The bad version would be something like fix this function. Okay? 3 words. You have some code that is broken and then you tell it fix this function. So what are you going to get from the AI? Well, the thing is you always get something. Okay? And you might even get something that compiles. You might even fix the test that was broken, for example. But then you have no idea if it's solving the actual problem because you didn't tell it what the problem was. You just said, hey, fix this. But I mean, you didn't really tell him what to fix. He doesn't know if the fix is a performance issue, if it's an UI issue, if it was a bug even to begin with. He doesn't know this. So now let's transform this bad version into a good version. So let's think about those 4 things again. Role, goal, constraints, context. So this would be a good version of that prompt. Act as a senior developer. This function should filter out duplicates, but it's letting some through when the ID field is empty. Don't change the function signature, don't add any new libraries, explain the root cause, and then suggest the smallest possible fix. It is the same exact task, okay? It is the same exact task, but a completely different prompt. And maybe you took, I don't know, 20 extra seconds to write it, but the output is actually going to be what you want. Because once again, he has a role, which is act as a senior developer. He has a goal, which is the function should filter duplicates, but it's letting some through when the ID field is empty. And then you're giving it rules, constraints. So don't change the function signature, don't add new libraries. And then at the end, not before we even talk about context, we're also telling him to explain the root cause. And why is this interesting? Because it makes the AI think. Maybe sometimes the AI gives you output, and still on the same context window, if you tell him explain the root cause or suggest why you did it this way, you're gonna make the AI think, and that is extremely important. So once again, these 2 versions would fix the same thing, except the first one might not fix the issue. The second one most definitely will be fixing your issue. So basically that's the trade. Yes, it's true you take 20 seconds extra to write that second one, but that one is going to be really useful for the intern, for the smart intern, for our AI. So once again, I am going to talk a little bit outside of code, okay? For the people that don't code. Here's the same 4 elements, but applied to something completely different. And something simple, planning a road trip, okay? So you ask the AI to plan a weekend drive. And the bad version of the prompt would be something like, plan a road trip for this weekend. And maybe it gives you a 5-stop map that starts on Friday morning. It instantly assumes that you have a car, and then you end up at a hotel that's actually been booked already, and the AI doesn't know this. So what would be a good version of this prompt using those 4 elements from before? Well, we would just start with something like act as a local travel guide, plan a Saturday day trip, drive only about 2 hours from Lisbon for 2 people. No beaches, keep it under 100 euros total, and you just send this, okay? There's already a big difference. First of all, the AI knows who it's being. It's being a local travel guide. It knows what the goal is. It knows what to avoid, and it knows where you're even beginning because you tell it that it's 2 hours from Lisbon. So once again, it is the same question as before, but it's gonna give you a completely different answer. And that will actually help you plan the trip a lot easier than with the first prompt. And then there's one more thing about prompting. So getting a little bit away from the examples now. There is iteration. So the first output that you get isn't always going to be right. As a matter of fact, there's a big chance that it's not right at all. So sometimes it is correct, depending on what you need, but more often it's actually not. So when it isn't, sometimes the move is not to start a new chat, it might be to continue iterating on the same conversation. So you write your prompt and you get a first attempt, you get a first output. You read it carefully, and then you look at it, but maybe it's not perfect still. So you iterate. You say something to the AI like, okay, this is in a good direction, but the fixed doesn't really handle the case, where the field is missing entirely, only where it's empty. Try again, and then you send it. So it's a new attempt, but then you also gave him what he failed at. And the context from before ends up being important. And maybe it is still not perfect, and if it's not, then you just keep going until you actually reach a solution. Let's think about your conversation as being the spec. So every message refines this spec. And most people give up after one bad output, and usually they like to start on a new chat or just do the work themselves. And the real ones, the ones that want to get value out of these tools, they go back, 2, 3, 4, 5 times. They iterate calmly until it's actually right. But now there's also the opposite. So when should you start a new chat? Well, usually you should start a new chat when you are totally stuck, like truly stuck, and you see the AI going in circles. If you see this happening and then the conversation, because there's context windows, they fill up, and maybe the AI doesn't need the context anymore, or it's completely polluted, well, in this case, you start a new chat. Or you start a new chat when you already finished your task and when you're moving on to something new. If nothing else is applies to this, then you just keep on building the first spec or the first initial chat. As long as the AI is still giving you successful output, then stay on that one. Keep iterating, keep refining it, keep giving it new rules, because everything in the same chat is going to be useful for the following answers. But once again, when it stops being useful, that's when you stop and you create a new chat. So now let's move on to part 3 of this episode. Let's talk a bit about trust calibration. So this is the third idea for this episode. And this is the one that usually bites people the hardest. So really, really listen to this one. AI always, and I mean always, sounds confident, even when it's completely and embarrassingly wrong. And there's no little disclaimer in the tone of their output. There is no such thing as him replying to you, oh, I'm not sure, but this doesn't exist. The model will tell you dead serious that a function works a certain way. And then you go execute it and it actually doesn't. So it's really good at making up details that sound right. And usually this is what we call hallucinations, which I'm sure a lot of you have heard of already. And hallucinations are not really a bug that can be patched. It's just simply how LLMs actually work. So what do hallucinations look like in development? Sometimes you're going to get output where the AI simply invents a function that doesn't exist, or it gives you a library that doesn't even exist, or maybe it gives you a library that you shouldn't be using. The idea is plausible, but the exact method completely made up. So it's like it sounds like he is right because he is always going to be so confident about the solution, but then when you actually look at it, it's something that should not be there. It really sounds like it should be there, but then it shouldn't. So this would be an hallucination. Sometimes it gives you code that actually worked in an older version of a tool without telling you that it's out of date. You're going to see this a lot, where you're going to get a lot of deprecated code, deprecated methods. And even though we might not actually treat it as an hallucination or call it an hallucination, the truth is, it is, because in his mind, he is very confident that that's the thing that it's going to work. So it's going to give you code that looks perfect, that it might even compile clearly, but silently, it's ruining things at runtime and you don't even know it. And sometimes it's going to create a complete new bug to you, or a complete new bug that you'll have to fix some other time, or break something that is in production, and you don't even notice this because what you told him to fix it actually got fixed, but then he didn't think about other things that could break. So that's where trust calibration comes into play, because he's going to be very confident with everything that he gives you. And once again, if we think about this outside of codes, it's still the same thing. So you ask AI to write, for example, a job application, and then somehow it decides to invent a statistic about the industry and about the salaries that the industry practices. And it's going to give it to you so in a certain way that is so convincing that you actually want to believe it, because he really structures it perfectly. And then if you actually do the research, you end up noticing that it's completely made up. So, ask it to summarize a contract or something like that. He might actually invent stuff that wasn't in the contract to begin with. And this is what we call an hallucination. This is just the model, the LLM, trying to guess something. So that's why trust calibration is really important. And basically, here's the kicker. The more confident that the sentence sounds, the more you should check it. So seeing stuff like the AI replying to you saying, "Oh yes, absolutely," or "You're right, this is the way that it should be done," or "This is the best way to do it," you should always doubt it. Okay? So once again, let's apply this to code. Always have verification habits. And I'm not telling you to be paranoid about the output. I'm telling you to just have the habit to review it correctly. So let me give you 5 verification habits, okay? So the first one, it's a given, but run the code, okay? Always run the code that it gives you. Just because it compiles, it doesn't mean that it works. So just go test it, see if the bug is fixed, read it, because maybe it's not even the best solution and you will need to iterate a little bit more. So run the code, read it, execute it, see if it did what you actually wanted it to do. Don't just trust it blindly. Then number 2, always double check anything specific. So this could be function names, version numbers, numbers that it creates, because he really likes creating magic numbers. And if the AI gives you a link, if you need the output for something, give me a link to the restaurants, list me 10 restaurants and give me the link to them, click the 10 links. Because links especially, he is really good at giving you links that don't even work. So there's a big chance that you end up in a 404 page. So yeah. Now, third verification rule, ask for reasoning. And this doesn't really avoid hallucinations, but it might help him get better results. So in your initial prompt, the prompts that we were talking about earlier, if you did something like, walk me through why you made this choice. Just this simple sentence in that prompt. If the AI was bluffing, the explanation will fall apart really fast, because when he will try to explain it to you, he will notice that he was wrong to begin with. And if the solution that he came up with is actually good, then the explanation will only make it stronger. So either way, you're always learning something here. You're either telling him to think about things, or you're actually telling him to explain them to you because he already did it correct. So once again, you'll learn from this as well. Now, number 4, watch for confident words. Like I said before, if the AI says absolutely, or this is the standard way, and that's exactly when you should slow down and really think if that's the best way, if that really is the way that he says that it is, if that's the standard way, if that's the correct way, if that's the way that you wanted it to be done. So strong claims need proof. And the AI almost never flags the difference for you because it is always confident. And now, the last verification rule, which is not truly a verification rule, but it's more of a thing that you should always have in mind. It's really important, maybe the most important part of trust calibration. You sign off on the code. You sign off on the output. Okay? It is always yours. Even though the AI gave you the output, you should be the one signing off on it. So if you ship something and something breaks, using the defense that, oh, the AI wrote it. This doesn't actually work for you. It's not the fact that the AI didn't write it, but whatever it is that the AI gives you, you have to own it. It is 100% yours. If something breaks, it's your name on the commit. So treat everything that the AI gives you the same way you would treat the first draft from someone you haven't worked with before. Once again, giving you the analogy of our intern that just joined the team. You need to be sure that what he has is actually not going to break anything. And you usually, since you're the one taking care of the intern, if he breaks something, you're still going to take some part of the blame. Okay? So read every line, question anything that really feels off, and approve only the things that you are willing to defend if someone asks you. Okay? And that mindset alone will save you more pain than anything, and I mean anything else, in this episode. So far, we've talked about lives inside a single conversation, a single chat, the same chat over and over again. So you write a good prompt, you verify the output, you iterate, and that's pretty much the single prompt game. And now what you've listened to will already make you better at it than most people. But here's the next problem. So you keep doing this over and over and over and over again. You open a chat, you define a role, you define context, you define 4 things at least that maybe 3 of them you can actually not repeat over and over again. And how we're going to take care of that are going to be the next 2 ideas. So this is where things end up getting more practical. Let's transform a single prompt into something that lives permanently, into something that you can repeat over and over again without prompting it again. So imagine having permanent instructions, because that's literally what Idea 4 is. Idea 4, instruction files. So there's 3 things that you need to know about instruction files. First of all, what they are, then what goes in them, and third, where they live. So let's talk about these 3 things in that exact order. So first of all, what are instruction files? An instruction file is a plain text file, usually in Markdown, that the AI tool reads automatically at the start of every session, every chat. And it's basically how you tell the AI just once what it needs to know about your project. So instead of typing context every single prompt, let's imagine where you take this and you put it in an instruction file. And that instruction file gets loaded every single time you start a new conversation. So without an instruction file, you always open a new chat and you always have to type your setup, type everything, language, style rules, what not to do, frameworks, blah, 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 blah. You can skip this and go straight up to the goal once you have an instruction file that already contains this. So that's pretty much the whole pitch. Stop retyping context. Write it once and then let the file do it for you. So this benefits even more when you think about a team setup, because this file should live inside a project. And if you have a lot of people working on the same project, there's a big chance that all of these people are also using AI. And if you have the same instruction file for everyone to be using, then everyone on the team gets the same AI behavior automatically. You get the same guardrails, you get the same rules, you get the same output, or very, very similar. So even if a new developer joins the team, you end up giving them free guardrails, literally, because let's remind ourselves that an instruction file is just a text-based file. It's a markdown file usually, and even a human can read that. So you're already making sure that whoever comes in and uses AI is going to have free guardrails. So second of all, what goes inside an instruction file? So it's pretty much like I've said already. However, usually you can put like 6 things inside of it. So what the project is and what it does, the tech stack that you're using, how to build and run, the project locally. Because once you do this, you'll be surprised at how much smarter the AI actually gets when it knows the setup that it's working on. You can also put coding conventions there, so stuff that lives in your team wiki, but maybe the AI has never seen it before. So stuff like this is going to help him generate better output. You can have architectural decisions, things that we already know would break, so you can tell it not to ever change that. So like just art constraints, things like don't add new libraries without asking, or don't rewrite working code from scratch. And basically, these files can vary in size, but you can start with something like 40 to 50 lines of permanent context. So you write it once, you close it, and from there on, all you have to do is actually give your AI a goal, because he's going to load that instruction file every single new chat. So once again, I'm telling you 40 to 50 lines to begin with. If you ever keep remembering things that you maybe should add to it, or that you maybe should update it, then go ahead, add some more stuff there. There's actually no size restriction. All that you have to keep in mind, though, is that there are token limits, or there are context window limits, and this file also counts for that. So try not to make it too big, try not to make it pollute the context window, but also don't leave it too vague. So start with 50 lines maybe, and then increment to maybe 100, 200, and then try to keep it around this size. So yeah, where do these files live? Which is the third part of this topic. So this really depends on the tool that you're using. If you're using Claude Code, usually you have a Claude MD file on the root of the repo. If you're using Copilot, and by Copilot I mean GitHub Copilot, usually it's inside a .github folder, and then it's called copilot-instructions.md. And there's a newer standard that is kind of working out for a lot of tools lately, and it's like a standard that they're trying to use for every single tool, which is a file called agents.md. So all of these 3 files live at the root of your project. They're there. That's where you give the instructions, the permanent instructions to your AI. And all of them do the same job, just for different tools. With agentsmd, you can even do it on a nested scope. So you can have multiple agentsmd files inside each nested scope. And when your AI is editing a file on that scope, it's going to find the closest agentsmd that exists in your project on that nested folder. So yeah, and if you use ChatGPT or Claude in the browser, it's pretty much the same idea. You can actually give it custom instructions. On Claude, you can open up projects, and it's just, okay, it's maybe not best for the code, but for everything else, this is how you can set up custom instructions or projects that end up living, and you end up having some context there just for those things alone. So, like I said, let's talk about something that has nothing to do with code. If I have a friend that writes a newsletter, every time he sits down to draft something in ChatGPT, he has to type the same setup over and over again. So he has to set up who the audience is going to be, what his tone is going to be, words that he really doesn't want to use, topics that are off limits. And imagine him doing this every single time, like 1, 2, 3 days in a row, weeks on end, months on end. It's just not good, okay? So imagine always having to type 3 or 4 sentences that actually set up the context before you even start doing something. So you're pretty much wasting a lot of time here. So most AI tools will let you save that once now. So you write it down once, put it in an instruction file, and you end up saving a lot of time by already having the context that you will be permanently using over and over and over again. So now we're going to talk about the fifth idea. And the fifth idea is a little bit comparable to instruction files, but it's agents. So we've talked about instruction files. We know that the context of the project is now, loaded automatically into the context window every time you open a window, every time you start a new chat. And that's great. But there's still an issue, or maybe somewhat of a problem, that it still doesn't solve, which is the instruction file is telling the AI about what the project is. It gives out some background, and it's perfect for stuff that is permanent, that is always true. So it's your stack, your style, your rules, etc., etc. But it doesn't help with the jobs that you keep doing over and over. Like those tasks that you keep asking AI to do, for example. And the one thing that comes to mind is code review, for example. So every time you run your AI and you prompt them for a code review, and you ask it every time you open a pull request, or maybe, I don't know, maybe the unit tests that you have to write the same way every time, these things that are usually repetitive, they really are not about project context. Even though they're repetitions, they won't fit in context. So it's just about doing the same job, the same way, same output again and again. And typing in your window, code review this according to rules 1, 2, 3, 4, etc., or write unit tests for this following the pattern, blah, blah, blah. That means you have to still give out this context every time. So think about instruction files, but instead of an instruction file, an agent. And that's pretty much what agents are for. So agents are simply an AI that has been set up to do one specific job. So usually it has a persona, it has a defined scope, and a clear format for what it gives you back. So think of it like the difference between asking a colleague for help in the hallway versus having someone whose old job is that thing. So, in a hallway conversation, you always have to explain, to your coworker everything from scratch. And if you already have a dedicated person that sits in the lab that does the same thing over and over and over again, they already know the drill. So this is pretty much how an agent operates. So once again, let's go back to examples that might actually be useful and that actually pay off a lot of the times. First of all, we're going back to the code review agent. So imagine that you've spent a lot of time doing a change, or with the help of AI as well, it doesn't matter how, but you point your code review agent at this change and it's going to give you the same kind of feedback every time. So if you have in an agent file that you want the issues sorted by importance, or you really want to look just at what changed and you don't want suggestions to rewrite things that are working fine, then you have these instructions in a code review agent and you can just call him when you want. So you don't need to give out rules about how we should do the code review. You just say, invoke the code review agent after this. Or now that everything's finished, invoke the code review agent. And the code review agent will do things exactly the same time every single time. Another example that I can give you, test writing agents. Once again, you give it a function that still doesn't have a unit test, and it's going to write the test. And if you think about it, agents are pretty much like instructions. They should be the same kind of MD file, or the same exact MD file for your whole team. So imagine agents as being new members of your team, new interns, new juniors, okay? So you end up getting very similar output from person to person. One last example that I can give you in terms of code, you can have an agent that simply writes release notes. So you give him the list of changes, or he analyzes it by himself, and then it gives you back clean, human readable notes in whatever format your team usually uses. So if you sometimes have to write an email with new features, at least your team is able to generate it the exact same way using the same agent. So each one of these agents usually has a job description that is written once and then used forever. Once again, for the rest of the audience, a non-code version as well. You can have a designer, and every Monday morning, this designer takes notes from the previous week and then turns them into a summary that the team can actually act on. So, it's the same format every time. It has some key themes, it has notable quotes, open questions, etc., whatever. And when I talk about a designer, it could be anything else. And you're just redoing this job over and over every week. And maybe it only takes you an hour, but imagine turning this into an agent. So you write the format down once. So you give it the structure, you give it the tone, and you give things that actually count as notable quotes versus noise. So like examples of what not to do versus examples of what to do. And then everything that you do is pick up the notes from the past week, give it to your notes agent, and then, instead of taking 1 hour looking at those notes and coming up with something, in 2 minutes, your agent is going to do it for you. So you end up getting the same output all the time, or at least the same format, without too much work. And you end up saving a lot of time this way. So whatever you do more than a handful of times, that's a candidate to being an agent. So anything that you see a lot of repetition, constantly doing the exact same thing, think about it, because you might actually have the possibility of implementing an agent there. Then there's also some reasons why the agent is something that really matters. So first of all, consistency, because the agent is going to behave the same way every time. There is no drift whatsoever. There's no such thing as re-explaining what he has to do. So back to the example of code reviews, the output of code reviews is always going to look the same. So as long as that instruction file doesn't change, as long as that agent MD doesn't change, then it's going to be the same no matter what. It doesn't matter if you're running it on a Monday, if you're running it on Friday, if you're doing it at the start of the sprint, it doesn't matter, because it's always going to be consistent. It's always going to be the same way. Then the second reason it matters is the speed, because like the example that I gave you, you don't need to be writing a bunch of context anymore. Your agent does this job, so you just call him, you give him the goal, the little sentence that he actually needs to begin, and then the rest of the brief is already done. So just to close with a summary of this, the full picture kind of looks like this. And try to visualize this. So you have your chat for one-off questions. Then you have instruction files for the things that are always true, that are always persistent about your project. And then you have agents for the recurring jobs that you don't want to keep rebriefing. It's this simple. And if you're a newbie, you don't actually need all of these three things to start. But knowing the layers exist already changes the way that you're going to be using these tools, because you're going to stop treating every interaction as a one-off. You start building something systematic. You start building an AI system. So just one more idea before we actually wrap things up. We're going to talk about the orchestrator mindset. So from now on, I want you to think of yourself as the one in charge, not just the typist. And what do I mean by this? It means that your job from now on is to decide what needs to happen. It is to pick the right tool for it. It is to give that tool what it needs to do the work, and then review what comes back. So you decide, you direct, you review. And this is pretty much the loop. It doesn't matter what the task is, this is the loop. You decide, you direct, you review. It's okay, ship it. It's not okay, you decide, you direct, you review. So you are not in the chair to write everything yourself anymore. Those days are pretty much over. You're in the chair to make sure that the right thing gets made by the right tool with the right context. Once again, orchestrator mindset. And that's the real difference now that AI exists. So the people who get most out of AI And when I mean the ones that actually ship serious work and they're not just using it for autocomplete or to generate something, personal or whatever, they all have this in common. They've stopped thinking of AI as a thing that they're using, and they started thinking of themselves as a team lead with a small team of specialists, a small team of agents, a small team of AI. And once again, like we started the episode, a small team of interns. So, the right tool for the right job with you making the calls. Let's repeat it again, orchestrator mindset. So, that shift in your head will change more about your output than any specific tip that I could give you. Okay, so now let's wrap things up. Let's talk about 6 takeaways that we take from this episode. And we're going to do it fast. So, number 1, you are always the one in charge. AI does the work. You direct, you review, and the quality of the output equals the quality of your input, of your brief. Number 2, 4 elements for a strong prompt: role, goal, constraints, and context. Memorize these 4 things and use them as a checklist every time you don't know how to begin a prompt or any time a prompt isn't working. Number 3, iterate, don't restart. So the first output is rarely going to be perfect. So your conversation is the spec. Keep refining in the same chat unless the AI is actually stuck, unless you don't need that context or that spec anymore. Number 4, just because the AI is confident, it doesn't mean that it's correct. So verify anything specific. Run the code, check the source, especially when the AI sounds extra sure. Number 5, write your instruction file. It doesn't matter which tool you're using, it has a way to save context once. So find it, use it, and stop retyping the same setup every session. And last but not least, build agents for the jobs that you keep doing over and over again. A code reviewer, a test writer, a release notes generator. Whatever your recurring task is, write the brief once and then stop reinventing it. Make it permanent. So the question that I want to leave you with, which is the one that you can act on this week before the next episode, is what's one thing that you keep retyping into AI? And every time you open a chat, there's something that you're giving it. There's one piece of context, there is one rule, one constraint that you find yourself repeating in every chat. Write it down, and that's going to be the start of your instruction file. So that's how you begin. So yeah, thanks a lot for being here for the first episode. I hope it helped you the same way that a lot of episodes, a lot of other podcasts have helped me come up with ideas. Hopefully there's a lot more coming, so you will be hearing from me soon. We're going to be talking about a lot more things, going more in depth with different scenarios, different things. We can talk about skills next. We will talk about a lot of things in the world of AI. So once again, thanks a lot, and I will see you next time.